basically our main materials have been discussed. So now we are focused on applications and how if we want to write a paper or do some research in data mining. Yeah. So first, if you see some journal papers in data mining, in general, there are two different, how to say, two different. The first one focus on implementation, only on implementations. So in that kind of paper or in that kind of research, we apply existing algorithms, and then the discussion or experiment, they are only focused on result in interpretations and of course recommendations. So if you are working in this area, yeah, make sure that we can really get insight in valuable information from the result. So do not only show like, oh, this, for example, we do the predictions, for example. And when we do the prediction, then we stop the interpretation, or we stop the, wait, something's wrong with my Zoom. Okay. So when we, after we do the, run the algorithms several times, because we want to make sure that the result is already stable, then we find the result. So we really have to make sure what is inside, from what insight we can get from the data, what information, valuable information. And of course, we hope that we can give recommendation from our results. The recommendation can be, let's say that this is, usually recommendation will be about the managerial, what we supposed to do to solve the problem, for example. And in this case, so after we run the program, we have to make sure that, okay, our result is good enough. Good enough means, for example, we can show the error rates or the accuracy, for example. Then after that, uh, after we sure that our result is good enough for us, then we give the recommendations. This kind of paper, we can submit this kind of paper into the application journal. For example, if we are doing data mining for management or marketing, then we can submit this into some management or business and management papers. The second type of the paper or research in data mining, they focus on methodology or algorithm development. In this area, I can say that first, some research, they propose a framework, a new framework in general. So the new framework in general, they basically combine some existing algorithm. For example, for preprocessing, they do what kind of preprocessing, and then for preprocessing itself have so many pre-processing, have so many things we can do in preprocessing. For example, how to deal with the missing value, and then how to deal with the outlier, for example, outlier. Sometimes we also have to do the feature engineering. Then after we do this, we process the data. Process the data itself, it can be the main algorithm that I can say in the general, yeah, main algorithms. And this is the additional. So they add some new algorithm or another existing algorithm, but combined with this algorithm. So let's say this is additional algorithm, which of course the function of this additional algorithm to improve the performance of the main algorithm. Okay. If you combine of this, so that's why I say we can also propose a framework for data mining. So missing value, maybe some existing missing value algorithm and outlier, also feature engineering. There are so many features engineering. We propose among so many algorithms for feature engineering, which one is the good one for uh, a certain type of data, for example. Yeah, so we can propose this framework. Or this is one alternative. Second one is modify existing algorithm. This is really focus on the main algorithm. For example, k-means, and we modify k-means, for example. But we don't focus on the framework. So the pre-processing can be, we are not focused on pre-processing, only focus in modifying main algorithm, existing algorithm. Okay. The third one, of course, is totally new, very new algorithm. Okay. So for this kind of research, algorithm development, after we propose the algorithm or the framework, we should do validation. Okay, so this is the very important step in this kind of research. For the validations, the easiest way we can apply our algorithm, our proposed algorithm, is benchmark data, because the benchmark data already have the correct answer. So we can make sure that we can validate our result. And of course, because we propose the new one, we one way to persuade the reader that, oh, this our idea is good enough and can give promising result, we have to do the comparisons. So we have to compare with some others algorithms. In this case, we don't need to mention like, oh, our algorithm is better than the algorithm in another paper. No need to say that. Just do comparison in general. Yeah. Okay. Okay. After that, some paper they give a more comprehensive results. They give more information. So after they do validations and they compare, and then they can persuade the reader that our proposed algorithm is better or can give promising result. They give simple implementations. So they implement their proposed algorithms in some new study case, the real study case. I mean, so it's combined with this one. But in that case, usually the result is, I mean, the result interpretation is not as deep as this. Yeah. So just simple implementations and simple result interpretations. Okay. So this kind for A focus, we can submit into the implementation journals, study case journals. For B, we can submit in the, let's say, some computational journal. Focus on methodology. But it is depend on how complex is our new algorithm. For example, if we propose the framework just like this, the first situations, the first one, this one, still we usually our change, we can get higher change if we proposed in the implementation journals. So if we propose a new framework like in the first scenario like this, I suggest to add one study case, at least one study case. So this one should it's better if we add study case. Okay, then we can submit this paper into related journal, a journal related to the study case. Yeah, for example, in the medical, so we can submit the journal in the medical science, for example. Okay, or for example, Arvin want to make a new framework and then apply in the educational case study. So you can submit this paper in the journal about education. Yeah. But if we are working on this, the second and the third, modifying existing algorithm and a new, even you make a new algorithm, you can submit into some computational science, computational science journals. Because it's focused on computation. Okay. Okay. Yeah. In for this case A, case B, I will not say that case B is better than case A. No, of course not. Both of them has their own contribution, of course. For B, focus on make a new algorithm. For A, focus on solve the problems. Yeah, so of course both of them has their own contributions. Okay. Okay, let's start look for some papers. Yeah. For example, the classification. We start from classification. This is one paper focused on implementations. So this paper they use neural network and regressions methods for this one. They want to predict the sewing thread consumptions of genes. So this is the manufacturer, clothes manufacturing, because they say that why we need to predict the sewing thread consumptions, because from this prediction we can the prediction can help us to predict suitable thread consume. So this is will be we can uh, predict like how many inventory we should have, for example. Yeah, and then we can reduce the stocks unused and then allow us to use a better quality of sewing thread for the same cost, avoid the stock rupture, and many more. Yeah, so focus on sewing thread consumptions. In this paper, because they focus on solve the problem, they want to focus on the prediction. So you see that here they use an existing algorithm, neural network and regression. Okay, so why they use regressions? Because in their case, they actually have some independent variables. Let's say this is the independent variables, and this one is dependent variable. So the saving, how many the saving thread. Yeah, this is the dependent. In that case, they can use regression, the basic one, regressions, but they also want to try using neural network. Okay. In the paper, because we are focused on the implementations, so we have to present step by step the methodology, start from data collections, and then after, what kind of variables, why we choose these variables, this one, why we choose this variable, because we can say that maybe there are some other variables also uh, correlate with the saving thread, but why we choose this variable. Yeah, so we also have to give explanation why we choose this problem, these variables instead of other variables. Okay. So why, you also have to mention in your paper. Okay. Then data preprocessing. After data collection, we also have to show the data preprocessing. Data preprocessing. For example, data preprocessing. I think I give this. Oh, I give it. Data preprocessing, for example, if there are some missing value, for example, or do we need data normalizations? Yeah, so data preprocessing, please give discussion in more detailed discussion about how we do the data preprocessing. Okay, and then when we working on the processing algorithms, let's say for this case, they have two algorithms. They use regression and neural network, multi-layer perceptron. Yeah, and. So if we use a neural network-based algorithm, first we have to show the architecture of the neural network. For example, this is the basic architecture of the neural network used in this paper. So we have to show clearly what is our input, or in our input layer, how many nodes, for example, how many nodes, and then for each nodes, of course, each nodes will represent one variables. For example, let's say this one is this one. So uh, we have also informed the reader like these variables. This is continuous variables, numerical variables. So we only need one node to represent this variable. Okay, because this is, I say this is numerical and continuous variable, so only represent by one nodes. But for example, like this, sewing machine type. The type, let's say the type we have type A, type B, type C. And this is, of course, this is the uh, nominal data. Nominal data. Maybe in our data, the raw data, A equal to 1, B equal to 2, C equal to 3. But because this is nominal, not numerical, continuous data, so how to represent these variables? So if you go back to check our previous metric, our previous discussions, if we have nominal data, so in the neural network, maybe we can one variable represent by 3 nodes, only for one variables. Okay, so this way, the way we represent our data into the architecture also have to be discussed clearly. Okay, yeah, this is only the input layer. Then we go to the hidden layer. First, how many hidden layer we have? 1, 2, 3, I don't know how many hidden layer we will put in our architecture. And then for each hidden layer, how many nodes we are going to use. So we have to mention number of hidden layer, and number of nodes at each hidden layer. Next is activation function. So what kind of function we use this? In this case, this is the sigmoid. Yeah. So nodes, number of nodes, and also the activation function. And after hidden layers, we go to the output layer. This is the output layer. Output layer. Okay. Output layer. Sorry, the nodes in output layer is this one related to the type of the variable of output. For example, if the output is the numerical data, any number, for example, so we can use only one node. Yeah, but maybe our output is class 1, class 2, class 3. Can be, for example, low, medium, and high. So this is the ordinal. Yeah. So in this case, maybe in the output layer we will have, let's say, 3 nodes. 1, 2, 3. So similar with the input. The input should represent the type of the data, type of the variables. Output also the same. The condition in the output layer represent the condition, the type of the output. Yeah. So this, all of these, the step that we are used to process our real case data should be discussed clearly in our paper. Because why we need to do this, because we hope that the reader can do the same, can use our idea, although the algorithm is existing algorithm, but let's say, for example, in neural network itself, we can have many different architecture. Yeah, so if we discuss, make a clear discussion, then the reader can use our idea. We can give more contribution to the reader. Okay, then in this case, in this paper, I mean, they compare the neural network result with the regressions. Of course, regressions in terms of complexity, for the algorithm complexity, regression is simple, more simple than neural network. So that's why they compare with the regression to see which one can give a better result, neural network or regressions. Okay. uh, for this paper, if you go to check this paper, maybe I can give you all the papers. This paper, uh, there is some room for improvement for this paper. For example, we can do the parameter setting. Why we need parameter setting? Because neural network, the neural network involve so many parameters. There are so many parameters in neural network. Let's say the architecture itself. How many hidden layers? This one. The number of hidden layers, number of nodes, what kind of activation function they can use. This is can influence the result. So that's why my suggestion, if you want to apply this kind of algorithm, please do the parameter setting analysis. Yeah, because maybe different parameter can give us a better result, can give different results. So it is better if we can show the parameter setting analysis. Try to work with many different architecture of neural network, and of course with different parameters. So we can give uh, our discussions, our contributions is not only about how to predict the trade consumption, but also like we can say that, oh, for this kind of data, the data for this kind of data patterns, what kind of neural network architecture can work better. That can also be our contributions for the reader. Okay, and the second one, I see that in the paper they don't give the training and testing analysis. So of course we have to do this. Yeah, for our own research, we have to do this training and testing. Okay, And of course, we should give more analysis in the case study. Because in the paper, if you see after they give the uh, error or accuracy from the algorithm, then they give only very few explanation about the study case. Maybe I will show
Dr.
you.
Dr.
Yeah,
Farah,
yeah.
would it still be okay not to show the training and testing?
Uh, I can say it is not okay because how do we persuade the reader that oh, this algorithm is all good enough? Because for example, where is my slide? Okay, let's say we have the data, the real data. This is the real data. Okay, then if we use 100% of this to train the neural network, or let's say in general to train the prediction model, yeah, our model is only developed based on our historical data. Okay. So focus only the model, focus only the pattern in this data. Okay, but can you make sure that our future data have the same pattern with this? Sometimes most of the case we don't know for the future data, of course. For example, this is the time series data. Make simple example. Time series data, for example. This is the maybe this is the number of demand, for example. But then at some point there's decrease like this. So if we, for example, this is the future data. This is our historical data, existing data. So if our model only developed based on this, then if there's some significant differences in the future data, then our model cannot handle the situations because not general, not yeah, it is very specific to a certain pattern. Yeah, so it is for this kind of research. It is very required to do the training and testing. So please divide the data into, let's say this is the training, this is the testing. Okay, because the training we develop the model, and then we test performance the model using the testing data. Okay.
Dr. Farah,
Yeah.
how about if it was only explained that the training and testing data was used and then 80/20 and then it
Mhm.
resulted to this, but did not show like the procedure? Would that be fine?
Do not also procedure. What kind of procedure?
They did not show the training and testing. They only explained that the accuracy is only 70%.
Oh,
Would
what kind of accuracy? No, just one value, one accuracy.
Yeah.
Okay. So let me give example. For example, uh, we have a class. When we study maybe junior high school or their school, we have homework. Yeah, usually our teacher give us homework and maybe give homework, exercise, and then small quiz maybe. Yeah. Okay. So if you can imagine if the teacher finally give our final exam, but the question in the final exam actually the same questions from the homework, exercise, and quiz, exactly the same equation, uh, question. Sorry. So what do you think? can we get a good result for the final exam?
Yes.
Yeah, why? Because
It's the
we know
same.
the question already, right?
Yeah.
Okay, so second case, the teacher give us homework, exercise, quiz, but then the final exam, different questions, but some questions maybe have the same pattern with this. Of course, different number, but maybe the same concept. Yeah. So which one is more fair, A or B? Which one can really uh, teach the students?
B.
B. Yeah. This is also what kind of what happened in neural network or this kind of prediction algorithm. So if we only use all data to uh, develop the model, and finally we saw, oh, the accuracy is 70% or maybe 90%. Of course, the value is good enough. Why? Because the model developed based on this data. This is the all 100% data. We develop the model. The model will have the accuracy, let's say 90%. Of course, this accuracy can this model can give very good accuracy. Why? Because the model itself is developed from 100% data. Of course, this model is good for this data because it already set to suitable for this data. Same like case A, the final exam, the same question with the homework, whatever, exercise, quiz. Yeah, so the accuracy is 90%. But what we should do if we develop the model, we have to prepare this model for future data. So we have to train, actually, we have to train this model for the next data, which is it is unknown. For like the case B. In the case B, the model is trained using this exercise questions, for example, and then we test with the new questions. It can be totally new, or it can be uh, a little bit different number with the same concept. So B is more fair because the model, we prepare the model for the future data. Okay.
Ah, another question, Doctor.
Yeah. Yeah, it's okay.
for for we would be the one to choose the training and testing set from our data, right?
Yes.
So what if, for example, we randomize 80-20, but do we have to test another like 70-30, and then how many times should we do the training and testing?
Okay. First, for training and testing, uh, it's true. We have to choose which one is training, which one is testing randomly. Yes, it is true already. And so we can also do this, do that kind of your questions in our research. For example, okay, for training and testing, we, for example, first scenario we do 80-20, 80 for training, 20 for testing using random. Okay, the first scenario. You also can use the second scenario is 70-30, random also. My suggestion is we can do several scenario if you want a more comprehensive analysis. So there is not really rules like, okay, you have to like training is better. You we have to have more training data than testing data. Because some paper they also use like 40 for training and 60 for testing. Yeah. So to answer your question, I think for me, my suggestion is you can test some scenario, and you can give more insight for your paper.
Okay, Dr. Fair, thank you. And
Your
then the result will just simply be per scenario, or do we have to get the average of accuracy and
per scenario.
oh okay.
You can have like that. And of course, after for the final, because we have to give at the end, we have to give the analysis. So after we have so many scenario here, finally you can say, okay, this which one is the best one. Okay. So after the best, you find the which one is the best one, then you do the analysis for the case study based on the best result, best scenario.
Okay. Thank you so much.
You're welcome. Yeah. So in our paper, uh, sometimes some students ask me, is it complex enough to publish the paper with this work? And then I say, maybe this some things we can make it looks like it is simple case, but a simple case, if we can design the experiment, we can design the cover, let's say it is the cover of this case, and make it looks like more very complex, then it is also uh, can be an interesting paper. Okay. Sometimes I give example to my students like, we are going to sell lemon tea, but maybe you know, if we buy a glass of lemon tea in a street vendor, it is much more cheaper if we buy a lemon tea in a hotel restaurant, right? But the product is still the same. It is a lemon tea. But why a lemon tea sell in the hotel restaurant can be sold with a much more expensive than a lemon tea in a street vendor? Because uh, lemon tea we can make sure that, for example, a lemon tea in the hotel restaurant can be more clean, or more, the packaging is much more beautiful than the one in the street vendor. Yeah, so this is also what we do in our research. The same case, if we can make a very good paper, writing and experiment, we can give the more scenario for the experiment, then we can write more, we can give more to the reader. So it becomes very interesting case. Okay. Any more questions? No? So I
None for
continue.
me, Dr. Fair.
Okay. Now, second question, second paper. So the second paper, this one is predicting students' performance in higher education institutions using a decision tree analysis. Okay. So in this paper, they want to predict the student performance, because they say that for student as educational institutions, if we know like student performance, then we can or we can decide what kind of system which can improve the student performance. So in this paper, the goal is predicting student performance based on some variables that they identify that those variables can influence the student performance. Okay. So again, this paper focus on case study. Okay. But to solve this case study, now they provide three different algorithms. So they have, in general, they have three scenario algorithm. This one, this G4H, you also can, sometimes the name is C, I forget, C4.5, C4.5, decision tree. This is decision tree algorithm. Okay. The second algorithm, this is the random tree. Random tree is, if you remember, this is still the decision tree algorithm, but there's no pruning in this algorithm. So the tree keep growing until data in one leaves, they are in the same 100% from the same class. Okay. The third one is REP3. So REP, this one, the reduced error pruning. Okay. So different algorithm for pruning. So this algorithm was, I forget what year they was proposed, but basically this algorithm modify the, for example, we learn about the decision tree algorithm. Okay, but here in this algorithm they modify the pruning mechanism for the tree. Okay, so this paper apply three different algorithms. Yeah. Because they focus on the study case, so they give a comprehensive, quite detailed explanation how to do the experiments, what they did in the paper. So first, they do data collections using questionnaires. Okay, maybe I will show you the questionnaires. Okay, so this one, they give this is the questionnaire description, not really the questionnaire, this is the description. So they have many questions, and they show us all questions in the data. Not question, I mean the description of each variables. So for example, they have demographic data, and this is the list of the questions. Okay, and this is the type of the data. Yeah. Next is the social informations. Okay, this your status, are you working or not, living with parents or not, uh, and family conditions. And they also show us the type of variables. Okay. Then is the academic informations, number of failed courses, absence days, and some others, including GPA, year of study. Okay, and this is also the what the variables. Study skill. Yeah, they also give the study skill, and this is, I think this is the Likert scale. Yeah, and motivations, also the Likert scale, and then personal relationship. I have ability for making, yeah, this is the Likert scale. What else? Health, and then including emotional health, they mention this, and time management, this one, Likert scale, money management, uh, personal purpose of the educations, yeah, and then career planning, resource needs, and self-esteem. Okay. This paper is quite good because they give us very detailed, step by step, what they do during the experiments, including what kind of the questions, and then what type of the data they mention. Yeah. So why we need this kind of informations? Because if the reader want to do the same experiment, then they can give us, we can give them valuable information. For example, oh, if you want to, let's say, if you want to measure the personal relationship, then you can use, for example, this kind of questions. Yeah. Okay, so give more contribution from our result, from our research. And we need to know what type of the variables, yeah, because in terms of the algorithms, different variables, you know, that different type of attributes, different type of variables should be treated differently. Yeah, so this information is very important for us. Yeah, and also we have to make sure that this kind of data type is suitable of a certain algorithm. Okay, there are so many variables. Okay, and back here. Then continue to data preprocessing. Okay, so from the data preprocessing, okay, first what they do is they solve the missing value. So because they have 161 respondent, they think that okay, and then they check how many rows which has the empty value. Finally, they find out that from 161 there are 10 row or 10 respondents, which is not complete answers. So they thinks that okay, we just remove this 10 respondent. So finally, they have 151 instances. Okay. Then they also do reliability to check the reliability value of dependent variable of the study, but this one is in general. So here they use statistics. Which one? Which one? They use statistic to calculate the reliability. This one using Chromebook Alpha. I guess you know this already. If we can calculate this using SPSS, for example. Okay. Then okay, why they give also the reliability value? Because the authors they want to persuade the reader that all questions in our or all variables in our research, they have a reliability value of the dependent variable in the study. Okay, and then the next one is feature selections. I think because they're aware that they have so many features, they have so many variables, so they do the attribute selections to select which among in total they have 60 variables. Yeah, so they using the correlation analysis, this one, to calculate the correlation between each questions to the dependent variable. Okay, this one. They try to find the most closely related attributes that affect the class. Okay. And of course, they can ignore less related attributes from the model. Okay. They use Pearson correlations to calculate the correlation between each questions to the, let's say, the class. Okay. And finally, they decided to eliminate the last 20 questions to increase the accuracy of the result. Again, they say to increase the accuracy of the result. This is still a hypothesis. Hypothesis, yeah. But if we do this, then we have to prove that if we eliminate some question, then the accuracy will be increased. Will increase. Okay. Oops. Back to the paper. Okay. Here they give all correlation value of all questions. Yeah. I think they already sort this question in based on the correlations. Okay. Okay, after they select the result, they select the features here, variables. So finally, they mention also that they use the tenfold cross validations to give us the best model. Okay, yeah, here, so applying the algorithm and evaluate the result. So they also do the cross validation. Okay, and then beside the cross validation, they also have several scenarios. So in this paper, the first scenario, they use oh, not they have so many scenario. Okay, first different scenario because of they apply different algorithm. Like for example, like this G4H and random tree and REP3. Okay, then um, another difference is before removal attributes. It means that before we remove this based on the feature selections. Yeah, this is based on the correlation, and they also have after removal attribute. Okay, so the first table and the second table has different attributes. The second one is uh, fewer attributes because some attributes already removed. Okay. And another different scenario is they also add one more features, which is the filter. Okay, so this paper they use what we call it WK. WK is a software for data mining. Okay, and in a way you can imagine it is like SPSS. Maybe you can download WK after this. It's not like Python. This is more like SPSS, so you can choose what kind of feature already included in the WK. So it's like click some value which one you want to use, and it's really like SPSS. Okay, and in the WK itself, they already have a feature to filter the attributes. Okay, so here apply meta classifier. They call it meta classifier. This is the attribute selected classifier. Allow us to combine classifier algorithm with attribute evaluator. So in the WK itself, it has their own evaluator to develop the tree. Yeah, so that's why they have without attribute filter and with attribute filter. So in total, they have 12 scenario. They have 12 scenario. Yeah. Okay. Uh, this is what I mentioned. Like to solve one case study, we can for the experiment we can give more different scenarios, so we can provide so many experiments here. Okay. And for each scenario, totally we have 12 scenarios, and then for each scenario, the evaluations is made based on true positive rate, false positive rate, precision, and recall. Yeah, here true positive, false positive, precision, and recall. Okay, so these are based on the confusion matrix. Okay. For decision tree or classification in general, although we can calculate the accuracy or error, it is much better if we also can show the reader our true positive, false positive result, recall, or precision. Okay, why we also need to show this, not only accuracy. Okay. Now you can imagine if our data, for example, our data, we have two classes, class 0 and class 1. Then in our data, let's say we have 150 class 0 and we only have 50 class 1. Okay. Then after we develop the tree, then in the case, in our case, maybe this is the prediction. In our prediction, in totally there are 160, no, 170, for example, class 0 and only 30 class 1. Okay. In this case, our accuracy, if we only calculate the accuracy, then our accuracy is still good. Why? Because actually in this case, we only have 20 error here. So the accuracy is 1 minus 20 over 200. Yeah. So it can be 90% accuracy. Looks good. Yes. But why it looks good? Because let's see, this wrong 20 is the ratio. The ratio is not balanced. We can see that 150 is the correct one. 150 is class 0 compared with only 50 class 1. This is the ratio is not balanced. So our accuracy maybe looks good, but if we go the true positive and false positive, for example, then we can get more information that, oh, okay, our algorithm is still failed to detect the class 1. Yeah, to detect the class 1. Because should be 50, but we only can detect 30. So if we only consider the accuracy, it is 90% accurate. But if we, let's say, we focus on the class 1, then we have only 30 over 50. Yeah. So it's we have to also make show the true positive and false positive. Yeah. Okay, and then this is the result. And finally, from trust scenario, they can give recommendation. Oh, which one is the best one for our study case? So from this, they choose which one is the best one. Not only that, they also compare each scenario. For example, without attribute and with attribute filter. So they make the analysis how good is the filter features. So they compare without and with filter attribute filter. Also from here, they saw that with the attribute filter, the result basically it's better. We can see, uh, 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 for example, this one compare with this one. Uh, this compare with this. Again for this one also, and in general with attribute it's better, although for example in this case, for example, let's see, this is compare with this G4.8 with without attribute it's better in true positive rate. We can say that. And then compare with this too. Yeah. And this one also, this one also, this one also. Okay. So first the analysis, they analyze the filter, compare, they give analysis comparison without and with attribute filter. The second one, they give analysis what is differences between before and after removal. Okay, because they want to prove this hypothesis. The hypothesis is if we eliminate less related attribute, the hypothesis is we can increase the accuracy of the result. So that's why they compare the result. So here they also give analysis. Okay, for after removal attributes, the accuracy or the result is better than before. So they compare table 4 and table 5 results. Okay, next analysis. They compare result between different algorithms. G, J4H, random tree, and REP3. They compare the differences. Which one is a better one? Finally, they also give the okay from all of this scenario, 12 scenario, which one is the best one. So they use the best scenario to give or to analyze the results. Okay, so this is the comparison between before and after removal. Okay, yeah, this one the summary they can get one insight they can give to the reader that questionnaires contains many unimportant questions that can be discovered by data mining algorithms. Large dataset and number of attributes in dataset affects the accuracy of decision tree. Okay, so with this simple experiment, they can give us this insight, okay, these informations. Okay. And they finally also they give the, of course they give the tree, and from the tree they give the analysis. Okay, any questions? No questions. I think you can. I see from Dr. Yogi class you have many questions. Very you have the data, and the data I believe there are so many questions. So you can learn from this paper about how they process the data. We can learn from this. Okay, no questions. So I continue to the next one. This is classification. Now we are working for clustering. Maybe you also want to do the clustering. Okay, so the third question, example, so the third paper, this is a generic hierarchical clustering approach for detecting bottlenecks in a manufacturing. Okay, uh, detecting bottlenecks in the manufacturing. So bottlenecks here in this case refers to event or a system in the or the machine in the manufacturing, which one can have potential to be the bottleneck of the manufacturer. Okay. Okay, so for this research, they propose a generic unsupervised machine learning based hierarchical clustering approach. And basically, this is the basic hierarchical clustering. We learned this before. Okay, to identify throughput bottleneck in production system, and then they propose the approach on the real world production system. Okay. Okay. So this research actually they use a basic hierarchical clustering, but what they propose, they say that they propose the approach. What kind of approach they propose? Because the hierarchical is still the basic hierarchical, so they propose the framework. Okay. They propose the framework to apply the clustering algorithm for detecting bottlenecks in the manufacturing. Okay. Uh, why this is also quite interesting research because detecting bottlenecks. Basically, the data is not a common data like in the clustering. Usually, we learn basic clustering. We have x1, x2, x3, and then so many data here, data 1, data 2, until data n, and then we do the clustering, cluster 1, cluster 2, cluster 3. Yeah, this is the basic clustering. But if we talk about bottlenecks in manufacturing, the data is the event. Yeah, so how to clustering the event? So that's why this is the contribution of the paper. They not only apply the basic one, but they propose a framework to process how if our data is not like in the basic or a common data. Okay, so here the detecting throughput bottleneck using machine event log data. Yeah, here. So this is the raw data, machine event log data extracted from the real world production system. Okay. Later they will use what they call it active period of bottleneck detections methods. So this is they combine like hierarchical with what they call it bottleneck detection methods. Okay. They in these methods basically they identify what is active state and inactive state. Active state is when an activity is conducted on or by a machine that is causing a blockage. Okay, so this is the state when it can have the potential bottleneck. Okay, active state. Okay, so because they propose the framework, so this is the framework of the paper. Start from data collection and then selecting a suitable bottleneck detection method, data preprocessing, hierarchical clustering, cluster computation, representative time series generation, and throughput bottleneck detection. Okay, so if we only focus on clustering, then this is the clustering, basic clustering. But when we talk about the framework, so they propose a new framework. Okay, we go to the paper. Let's see. This one. Okay. Um, New paper 2020. Okay. Yeah. Okay, so this is the paper. Okay, this research, although they propose a new framework, but because the framework is focused on a certain case study in manufacturing, so they submit this paper in the journal focus on the study case manufacturer. Okay. Okay, and then the framework I mentioned is they give a very big framework, so I cannot put in my slide. Okay, so this is the framework. This is the proposed framework. Yeah, so this is the main contribution actually, the framework. Okay. The framework consists of 7 modules. Modules 1, 2, 3, yeah, until 7. Okay. And in this paper, for each module, they give a quite detailed explanations. Yeah, so we can learn or we can understand each module from this paper. Okay, so this framework from database, of course, they have data collection. Okay, see, module 1, data collections. The real data is actually the event log from the machine. So event log is okay for machine 1. Let's say the unit 1. This is the unit produce unit 1. Start from maybe today, April 24th, 2021, 04, 24, what time? 0900, for example, until 2020, 04, 24, 09, let's say 10 minutes, for example, like this. So this is the real data, the event log. Okay, and of course the event log already convert into a timestamp, so they have this timestamp already. Okay, so for the event log, they have to define the time interval of interest for throughput that bottleneck detections. Okay, okay, why they have to define the time interval? Because maybe from the machine one to machine another different, this is the same machine ID. Maybe for different machine they have M2, uh, the interval time from different intervals. So we have to make sure that data from all machine one until machine, let's say machine N, they are in the same time interval. So that's why the time interval of interest should be defined. Okay. The minimum data required for successful application of the proposed bottleneck detection approach should cover enough past production runs so that the all events relevant to the analysis are well presented. Okay, so they we cannot say that okay the minimum data is 100 data. Is it enough or not? We don't know, but what we call it enough in this paper, if among 100 data here, they have the event of bottleneck, for example. They also have the event with not a potential bottleneck. So all the pattern is including into the data. So although we have only 50, for example, but if between the inside this 50, they already cover all patterns in the production runs, then is enough. Okay. Okay. So before we go here, back here. So here, this is the data collection. Then this after data collection, select the suitable bottleneck detection method. Okay, so the data is like this, for example. Okay, and why in the module 2 they need a domain expert to detect, oh, this is the bottleneck promising, this is not promising bottleneck, because the expert, they according to their research, the expert is the one who can understand, oh, for tool chains with this time step it's too long. The in general, in average, it should be a 0.4, maybe, for example. Yeah. So to detect this, we need the expert's judgment. So that's why in the module 2, they need a domain expert, the one who understand. Oh, this event is a potential bottleneck. This event is normal. This event is not normal. Okay. The domain expert, they ask the domain expert to explore the event data, event log data, this data, okay, of the present system to make sure that the necessary information required data have been included into the data. Okay, so this one, because the minimum data required means that already including all the pattern, so they need an expert judgment to explore the data and make sure that the data has enough pattern. Okay, then they also need the domain expert to identify which one is potential bottleneck, which one is not potential bottleneck. So they call it active paired bottleneck detection method. So the expert, the domain expert is including in these methods, active paired bottlenecks, because it can detect bottlenecks using blockades, starvation, or other machine by using all the action event. Yeah, okay. And module 1 and module 2 here from the framework, we can see that there is a looping. Okay, why? Because the data collections and then the data have been collected, give to the expert's judgment to make sure that the data have enough for the analysis. If it is not enough, then they collect more data. Okay, so that's why module 1 and module 2 they are repetitively they're doing like this repetitive until we have enough data. Okay, then if we have enough data, then we continue to module 3. Module 3 focus on data preprocessing. Okay, so let's see what is inside data preprocessing. Okay, module 3 data preprocessing. We have data cleaning. Okay, the data cleaning focus on removing events that were recorded outside the defined time interval. Okay, so because we want all data have the same time interval, so if the data is outside the time interval, a certain time interval, for example, this is the uh, time interval. This is the time interval that have been decided. So if there is one event data, for example, here, so we eliminate this. Okay, and then we also check the event logs and removing duplication. Of course, we have to remove duplicates and then removing events not interest in bottleneck detection analysis. Okay, so maybe in the manufacturing, there's not an event that is totally not related to the bottleneck. Okay, so they can remove that. Okay, and they also do classification of event logs. So because finally we want to identify which one is potential bottleneck or which one no, so they also do reclassify the event to active or inactive based on expert's judgment. Okay, for example, the event is producing this one description of as given by domain expert machine engage a production in a product, so this is the active, means that this kind of event is potential bottleneck. Okay, and that compare with waiting to unload. So machine waiting for unloading the product after operation. So expert judgment say that this is inactive, so it is not potential bottleneck. Okay. Okay, so this is the model 3. Okay, data cleaning based on the experts. The output of data cleaning is a clean event log data for all machines. Then after that, we classify the event log. Okay, and then the output is event log data of all machines containing a classification of each event. Finally, the output is the time series generation. Okay, so what is time series generation? Here, this is the production run. Okay, for each machine, different color, different machines. So the data becomes the like time series data because this is the production run from 1 to 30. Okay, and this is the active duration of the machines. Okay, so what we are going to clustering is not a single time data, but this is the time series data. So they want to classify all between, oh sorry, they want to clustering the data. For example, oh machine 1, machine 2, machine 3, 4, let's say this is including into cluster 1, cluster 2, cluster 2, cluster 3. Let's say cluster 1 is highly potential bottleneck, cluster 2 is medium, cluster 3 is low potential, for example. Yeah, but in this case, the data is like this time series. So of course, time series data, clustering time series data is different. Like uh, before, we only learn one non-time series data. So we have this data, and then this is cluster 1, cluster 2, cluster 3. Yeah, this is non-time series. Non-time series. But in this case, this is time series data. So the challenge here is how to develop the cluster, how to grouping each line into a similar cluster. Okay, so now the data is a line or a pattern of a line. Okay, so then this is the time series generation. After that, after we have the time series data, we go to the module 4. Module 4 is the clustering algorithm. So module 4 is actually the clustering. This is the clustering. Okay. You can imagine now the challenge is how to cluster the line. We usually cluster the point. Now we have to make a cluster from some lines. Okay. So to do that, this is the hierarchical clustering. So for hierarchical clustering itself, this is the just basic hierarchical clustering. Yeah, you know the hierarchical clustering, like this is the dendrogram of the hierarchical clustering. For example, machine 9 and machine 10 is close to each other, for example, and then machine 2 and machine 4, 7 and 8, and then the next one is machine 3. Yeah, this is so this is the basic one dendrogram. Okay, the problem is how to, let's say we have machine 1. Machine 1 is like this, the pattern, for example. Then we have machine 2. I know machine 1 nearby machine 13. So maybe machine 13 is like this. Okay. And maybe we have very totally different machine 3. Machine 3 maybe like this. This is machine 3. Okay. So how to calculate similarity between two lines? So similarity between two lines. I call it lines. Yeah. So here, if we have two lines to calculate, M2, M13 is more similar. The green one is M13. M13 is more similar to M1 rather than M3. How to calculate that? To calculate this one, there has many ways, many equations to calculate, but this paper they use it dynamic time warping. Dynamic time warping. Okay. So what is dynamic time warping? Okay, here, yeah, application of DTV. Yeah, because they want to develop the dendrogram, DTW, dynamic time warping. So in a simple way, dynamic time warping is like this. Let's say we have time series like this, and then we have another line like this. Okay, the period, let's say this is period 1, period 2. This is, for example, period 3 until, of course, we have period n. Yeah. So dynamic time mapping is calculate differences for each period. So this point, compare with this point, uh, plus this point compared to this point, and then continue to period 3 here, period 4 maybe here until all periods. Okay, so they actually calculate differences between each point in each periods and then combine it together. Yeah. Okay. So dynamic time wrapping. Okay. After they can get this dendrogram, after they can calculate dendrogram using dynamic time wrapping, so they cluster, they go to the module 5. So module 4 and only until developing the dendrogram. Dendrogram not yet tell, oh, which one belongs to which cluster. Not yet. This is just dendrogram. Okay. Now in module 5, then they finally decided, okay, so how many number of cluster? In module 5, they step 1 in module 5 is selecting number of cluster. Okay. For select number of cluster, they use expert judgment. So they have so many expert judgment in this paper. So according to expert judgment, they said that based on nature of production system, it was decided to partition the dendrogram at height of 300 result. So here, this is the height of dendrogram, and they say that maximum height or maximum differences is 300. So they cut all in. They put a line here. 300 is here. Okay. So here below 300, below line 300, it becomes one cluster. So for example, M1 is a standalone, so M1 is become one cluster. And then here, cluster 2, they have machine 9, 10, this 2, 4, 3, 7, 8. This belongs to one cluster, cluster 2. And then here, cluster 3, machine 5 and machine 11. And also cluster 4 is 1, 2, 3, machine 12, machine 1, machine 13. So there are 4 clusters. Based on the expert's judgment, say that maximum height is 300. Okay. To verify this, they also using the elbow method. So they calculate the SSE, yeah, and then for each number of cluster to find the elbow method. And for the this is only for verification. Okay, so for the verification, they find out, oh, okay, elbow point is also 4. So 4 cluster is the best cluster number of cluster for this data. Okay, then step 2, step after decided the number of cluster, they extract machine information for each cluster. Okay, so this is they already put each machine to the cluster, and of course they also extract machine information from the cluster. Okay, finally they try to interpret the result. Okay, in module 6, okay, this one module 4, and then module 6, module 5 is extracting machine information, and module 6 is the representation result. Okay, so this one, cluster 1, cluster 2, cluster 3, cluster 4, they to identify or to understand, to do the profiling for each cluster, they try to make a representation for each cluster. So for each cluster, they use average time series. Okay, average time series for each cluster to make it easy, because compared to this picture is very complex, so we cannot see the cluster. So what they do is they, for each cluster, they have the average time series, and finally they have this. So this is the average time series for each cluster. Okay, more simple plot, so we can get more uh, information because it's more simple. Okay, then finally they uh, interpret the result. For example, they say, okay, from cluster 1 to 4, cluster 1 has potential bottleneck because the active duration relatively always above cluster 2, 3, and 4. So this is the cluster 1. Yeah, you can see that, okay, this is most of the time always higher, has higher active duration. Only in what case? For example, they mentioned that, oh, in production run 10, in this case, cluster 2 is higher than cluster 1. Again, this one here. So this one production maybe 16 and 17. Cluster 2 is the highest one. Yeah, it is anomaly. Okay, then they also can say that, oh, okay, this one is the finding with throughput, but module 7 is determined by visual analysis. Yeah, this is, and then finally the domain expert. Okay, so from module 7, this is the finding. This one, active duration of cluster 1 is higher than other cluster. This is what I mentioned. Cluster 1 is relatively higher. So what is inside the cluster 1? Inside the cluster 1 is machine 6. So it mentioned that, oh, machine 6, finally we find out that machine 6 has the potential bottleneck. Yeah, okay. What else? For production run 10, this one. No. This should be production run 10 is this one and this one. Yeah. Cluster 2 has highest active duration. In other words, it may say that for this production run, primary bottleneck shift between the machine in cluster 1 and those in cluster 2. So yeah, this one, cluster 1. And so in general, cluster 1 and 2 for most of the production run are indicated as, sorry, this is as non-bottlenecks. Sorry, I switched. Non-bottlenecks. Okay. Yeah. Okay. So they this is the way, what I want to highlight is the how they represent complicated picture like this into a simple one like this to help us find valuable information. Okay. They also have a second study case. Yeah, so this with they apply exactly the same framework to the second study case. And finally, they have this is there are two cluster. Cluster 1 is machine 1, machine 2. Cluster 2 is 534. So this is the original data. Yeah, for no. This is only cluster 2 data. Okay, so they put the this one is a representation for each cluster 1 and cluster 2. And because cluster 2 has the potential bottleneck, okay, so they give a more detail. They do more detailed analysis, investigation, focus on cluster 2 because cluster 2 has potential bottleneck. Okay. Any question from this?
None for me, Dr. Pera.
Okay. So hopefully this paper can give you inspiration because sometimes we don't know, oh, this kind of problem can also can be solved with this algorithm. Yeah, so honestly I also just read this paper maybe last 2 weeks, I think. Yeah. Okay. Yeah, another example for clustering. Okay, This one using growing sum is self-organization map. Okay. So this algorithm, this paper, they propose algorithm, but this one is not totally new. This is just like combine several algorithms. So they have the main algorithm, main clustering algorithm. The main clustering algorithm here is SOM, self organization map. Okay, and because they find out that in SOM there are some drawbacks, so they add more additional algorithm to improve this SOM. Yeah. Okay, so here is the algorithm. First, maybe I should introduce you SOM first. So SOM is like, uh, let's say we have number of input data, x1 to xn, okay? And then in SOM, basically, we have n-dimensional data, and we want to mapping all of this data into a two-dimensional topology. Yeah, so we want to map in self-organizing map. We are going to map n-dimensional data into two-dimensional topology. This is the topology. Okay. Why they call it self-organizing? Because let's say we have, for example, like this. This is the picture. We have n input data here. So why it call it self-organizing? Because maybe for some data, let's say data one. Data one have variable x1 until xn. So data one is when we map into the two-dimensional is more closer to this uh, nodes, for example. But data 2 may be closer to this node. Data 3 may be closer to this node area. Okay, that's why it's called self-organizing. Okay, finally, what is the result of SOM? So the result of SOM, the data, we can get the data, most of the data goes to which area. For example, oh, this area have more data, and then another area is this area. Another one is around this, for example. So from this mapping, we can see that there are in general there are three cluster of data. The data here, here, or here. So we can see that with two-dimensional topology, we can capture the where the data located. So from the data location, we can see that most of data is here, here, here. So cluster 1, cluster 2, and cluster 3. Okay, so this is SOM in general. Okay, so why the motivation of this paper? First, why they have to modify SOM into a growing SOM. Okay, the motivation is like this. In basic SOM, so SOM always using n by n topology. So for example, 3 by 3. So the topology is 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is the topology, n by n. Okay. So the data will only choose between totally 9 nodes in the topology. Yeah, so data 1 closer to which node, data 2 closer to which nodes, until all data. Of course, in SOM, I can say that they are very limited option for the data because already said, oh, okay, there are only 9 nodes in 3 by 3 topology. Okay, but maybe the data needs more space. Let's say I have data 10. Data 10 is very far from other data, so should be another nodes here. Okay, so here, that's why we choose growing sum. So in growing sum, the topology, every time they have another data and the data needs new nodes, then they can provide new nodes. That's why they call it growing sum. So maybe they start from 2 by 2 topology, and because the variation of the data is very big, so maybe they can grow into any shape of the topology, maybe like this. Yeah, it's a free shape. I can say a free shape of topology SOM. Okay, growing sum. Okay, next, step 2. After we have the topology, okay, the SOM actually also including or involve several parameters. Okay, so how to fine tune the parameter automatically instead of set manually? So in this case, they combine GSOM with a meta-heuristic algorithm, where the meta-heuristic algorithm, basically meta-heuristic algorithm is an optimizer, focus on optimizing the parameter in GSOM. So the text, the meta-heuristic focus on find parameter which can minimize the error of the GSOM. Okay, so they combine these two for the clustering. Okay, and then for the methodology, because they want to provide or the meta-heuristic, there are so many meta-heuristic algorithms. Uh, they choose several meta-heuristic algorithms. For example, like B-colony, they compare to B-colony and particle swarm, and they combine several scenario here. So they for the experiment they have 1, 2, 3, 4, 5, 6 scenario with different combination of the algorithm. Yeah. Then they compare one by one. And because this is the new algorithm, so before they apply to the real case, of course we have to validate. Yeah. For example, if we make a new medicine, then before we sell the medicine, we have to do the experiment to make sure that this medicine is safe. Algorithm also the same. If we propose a new algorithm before we apply to the real data, we have to test this algorithm. Yeah, that's why we have to apply to benchmark dataset. Okay, so this is the benchmark dataset they use, several benchmark dataset, and they also do the parameter setup for all algorithms. Yeah, so they have the parameter setting analysis. Okay, and then after they get the best parameter setting for each algorithm, they run several times to check the robustness. Yeah, so uh, because you know there's sometimes this kind of algorithm involves the randomness, so we have to run several times. Don't run only one time. We have to run several times to check the robustness of the algorithm. Is it stable or not already? Yeah. So we have to run several times. And finally, this is a summary of computational result from 30 runs. Okay, you can do more, of course. Okay, yeah, so this is to show the average and standard deviation. Okay, and then after we can persuade that, oh, this algorithm is suitable or not, this algorithm is good enough to solve the problem, then finally we can apply to the real data. Okay, so for this algorithm, for this paper, they apply the algorithm in part clustering. So part clustering is in manufacturing. Usually group technology is to identify the cluster of parts to reduce the production lead time, setup time, processing time, working process, labors, rework, tooling, and routing. Yeah. Okay. So these are some example of why we need to do group technology or cluster the parts. Okay. And the data in this paper, it use manufacture product producing medical furniture. So the company produce the medical furniture, for example, like patient bed, operation bed, cabinet, and trolley in Indonesia. Okay, so this is the medical manufacturing. The data consists of 913 639 parts. The attributes is original shape, thickness, width. So this is the dimension, and then the machining process required for each product. Okay. So after we apply the data into the proposed framework, okay, this is the SOM result. So this is two dimension. Yeah, this is one dimension, two dimension, and the third dimension is actually number of data. Number of data in the nodes. For example, we have nodes here, nodes here. So the height here is number of data. Okay, higher what higher picture like this, higher shape means that more data in this area. Okay, so from this picture we can see that, okay, the topology may be like this, and I think like this. Yeah, this is the topology of the SOM. So you can see that this is the topology is not n by n but irregular shape. Yeah, topology is irregular shape, and then we can see that, oh, maybe the data located around this area, one cluster, around this area, second cluster, and the third area, most of the data. So this is the separateness of the data. Okay, then finally they do okay, the SOM result, they just give us, okay, this is the in general separateness of the data. So to find out a final result, they use the k-means. So the k-means here is based on the SOM result. So here the number of cluster already know here 1, 2, 3. There are 3 cluster, and the initial centroid is already find out by average of this data here, here, and here. Yeah. So the k-mean itself already improved based on the SOM result. Okay. So this is finally this is the result. Cluster 1, cluster 2, and cluster 3. Okay. And then of course, after we get the result, we have to give more information about the case study itself. So to identify or to make a profile, to understand the profile for each cluster, they try to uh, see characteristic for each cluster like this. So this is for cluster 1. This is the characteristic find out from cluster 1. This is the characteristic find out for cluster 2. This is for cluster 3. Yeah. So from this, we can recommend something for the managerial, for production, planning, for example. Yeah. Okay. Any question for class 3 for this paper? No? Okay. Continue. Okay, continue. The next one is still about clustering, but this one they call it, they use the fuzzy K modes. Okay, so fuzzy K modes. First K modes is a K means algorithms, but it is focused on binary data. So the difference is because binary data, they will K means to represent the centroid, K means using average of the data. K means using average or mean. Okay, but because the data now is binary, we cannot calculate the means, so they use modes. Modes is the most frequent data in that cluster. So the centroid represent by the most frequent data in that cluster. Okay, and then this is only modes, and they also add fuzzy theory into the K modes. So let's say this is the combination of fuzzy K means and the K means change into modes. Okay. Okay. And then besides fuzzy K modes, they also apply meta-heuristic algorithm to find number of cluster and initial centroid. So we know K means always require us to set number of cluster. We can use, for example, elbow method to find out number of cluster. And the initial centroid is random, basically. But this paper, this research, they apply meta-heuristic to find out number of cluster and initial centroid. So we don't need, as the user, we don't need to set manually number of cluster. Okay. So this is the algorithm. Of course, they show the framework. Yeah. Okay, and then again, they do the parameter setting analysis to get the best setting. And of course, the best setting run several times to check robustness to get the best method. And of course, we have to apply in the benchmark data and do some comparison. Okay, and after that, after we can uh, get the result and we can validate, we can verify that the proposed algorithm is good enough, then we can apply to the real data. Okay. Okay, that's it's for clustering. Any question for clustering before I continue to the association rules? No questions? Okay. If
None
no,
for me, Dr. Farah.
yeah. Okay. So let's continue to association rules. Okay, let's see what kind of application we can do for using the association rule. Okay, first, this is one paper, association rule hiding in risk management for retail supply chain collaboration. Okay, so this one, application of association rules for risk management. The algorithm is using the existing algorithm, so more focus on application. Okay, the study case is anonymous Belgian retailer. The dataset, the author also provide the dataset, so we can also use this dataset. Okay, the dataset was collected over 3 non-consecutive periods. Okay, so again, because this is the focus on study case, so they provide more information about the how they do the data collection and how they do the experiment. Okay, the data contains of 88,000 more than 88,000 transactions and have so many products ID. Okay, so this is for example. This is the example of the database. Okay, so for example, transaction one, this is the items in transaction one. Okay. Then they use the association rules to find out the rules. So they focus in this algorithm. In this paper, they are really only focused on finding rules inside this data. Okay. Okay. So here in the association rules, they try to use many different thresholds. Threshold is the minimum support and minimum confidence. Yeah, so they try different minimum confidence and minimum support. Why? Because different setup for minimum confidence and minimum support will give us different rules. Yeah, I hope you still remember. Finally, if they propose this using this threshold, okay, to discover 236 association rules. Okay, then after that they try to give explanation to some about some rules. So in the paper they give, for example, yeah, one rules is if the owner the customer buy milk, then it is also will buy Orion biscuits. For example, the number here is number of case. Okay, and this is they also show the support and confidence of these rules. Okay, so what is correlation between finding rules and risk management for retail supply chain collaboration? Okay, so this is the correlation. From the transaction, they find out that the customer will buy orange biscuit if they buy milk. Okay, so the retailer, they must if they want to restock or they want to make sure that the inventory for the milk is enough, they also have to make sure that they have enough inventory for Orion biscuit, because mostly the customer will buy both of them together. Okay, so the risk here, they mentioned the risk here is if they want to increase the orange biscuit sales, for example, then they also have to increase the sales of milk. Or if they want to make sure that the customer will buy orange biscuits, they have also make sure that we have enough inventory for milk. So, for example, what is risk here? If the store doesn't have milk, then the sales for orange biscuit also will decrease. Yeah, so this is the risk here. Risk of not having milk. They not only lose sale for milk, but they also lose sale from Orion biscuit. So this is the risk find out from the association rules. Okay, maybe we can find another rules. Yeah, so this is what they find out from the association rules. Okay, any questions? No. Okay, yeah, so again, I highlight that when we write a paper, although we use a simple algorithm, but if we can find out valuable information just like this, for example, then it becomes our contribution in this paper. Okay, another example, this one is, oh, so for if the first paper is focused on risk, second paper focus on dependency of for the inventory. Okay, so they said they in a multi-item inventory with a large number of items, purchase dependency among items is often observed. Okay, this one for example, stock out of one item may result in non-purchase of another item. Okay, so actually it is quite similar with the first paper, but the first paper try to use the angle, the point of view of the risk, but the second paper, this paper, using the point of view of inventory, and when they have to restock or purchase the variable items. Okay, so here data collection using 45 items uh, from around 8,000 transaction data. Okay, so here, because in this case, they focus on only 45 items. Maybe they have more items in the store, but because they only focus on 45, so the transaction data, this one, has been selected where each transaction data at least consists of at least one selected item. Okay, so for example, we have another transaction, but not include one items from this 45, so we will not use that data. Then they set the minimum support 20 and confidence 65%. Then they can get the result. Okay, so this is, for example, one example of the result. Rule number 1, kismis will buy basmati. So I think this is in India, so this is the common product in India. Okay, basmati rice, kismis. Yeah. Okay, so from this, the confidence is quite high and the support also here, 24%. So it is observed that stock out situation of kismis has the result loss of sale for both kismis and basmati. Okay, yeah, so this one, the customer actually come to purchase both kismis and basmati, but they purchase neither of them due to stock out of one item. Yeah, so as a retailer, we have to make sure that if we restock kismis, we also have to restock basmati rice. Do not only focus on one of them because they may influence each of them. Okay. Okay. Another example of association rule. But this one is application in layout. Okay, facility layout. So here the paper focus on improve facility layout based on the association rules. Okay, so here this is the emergency department in a hospital. Okay, so the aims is they want to increase patient satisfaction and employee satisfaction, decreasing travel distance in emergency department. So you can imagine sometimes when we go to a hospital, uh, if the layout of the hospital is not, we think it is not good. Usually, if for example, from the one polyclinic, for example, and sorry, we go to hospital, we go to registration first, and then after that, from registration, we go to the doctor, and then after the doctor, we go to the what waiting for the medicine, and then after that we go to the cashier, for example. Yeah, so we wish that all location that we are going to visit is close to each other. Yeah. To increase the satisfaction of the patient, we wish that all related departments should be located close to each other. So the patient, we are as the patient, we don't need to walk far away. Okay. So here, oops. Oh, sorry, I don't put more information. So here the data is the record of the patient. So the data is record of patient. It means that, for example, for patient one, they go to which department? Maybe department A, B, C, D. Patient two, maybe A, E, D, F, for example. Patient three, what department? And also the employee, maybe the nurse one go to which department? Doctor one, which department? Okay, so this is the data. The data consists of the items here. The items is the departments visited by each patient or each employee, each doctor. Okay, then they find out rules between, for example, if people, patient or nurse or doctor, go to department A, then they will also go to department C, for example. So it is better to put A and C close to each other because most people will go from A and C. Okay. So here they from the rules they find out, then they relayouting the facility. So for example, this is the before and this is the after rules. After finding the rules. Okay. Okay. Any question? Sure, you can use any platform to run the algorithm. I myself also use MATLAB to run the algorithm. Even I uh, honestly I just learned Python maybe this last 1 or 2 years. Before I always use MATLAB. I always use C and what else? Yeah, focus on C and MATLAB. MATLAB has a package already with similar with the Python. Python, yes, but because MATLAB is not free, it's very expensive for MATLAB. So that's why more people use Python because Python is free. Yeah, but actually before I use MATLAB more than Python. Any more questions? Oh, okay. So if we back to our purpose of doing data mining in the first slide. So here for research in B type means developing algorithm framework, uh, we have to do more in programming. Yeah, we have to have more programming skill. Why? Because we have to modify the existing, at least we have to modify existing algorithm, or we have to, let's say, okay, finding outlier is using existing algorithm. And after that, we combine with feature engineering. So at least there is a interface here, right? Although the outlier detection using the existing algorithm, feature engineering using the existing algorithm, but there is an interface here. So at least we have to know how to writing the code for this. Of course, if we talk about modifying existing algorithm, if my suggestion, if you want to work on modifying an existing algorithm or even develop new algorithm, uh, do not use package. For this case, do not use package. Do not only use a package. Okay, but we can learn from the package. So what I did usually is okay, I search the package. If I want to modify, I search from the package, but then I read all step by step what happened in the package. It is in the MATLAB also. MATLAB have the package also, so I open all the programming code in the MATLAB. So then I modify this. And of course, if we want to do this, before we do the code, please understand the basic concept of the algorithm. So we know which part has the room for improvement. Okay. Okay. Any questions?
Dr. Farah, I would ask for
Yeah.
tomorrow.
Yeah.
So will be for the consultation, you will be asking us one by one for the.
Yes.
Okay.
Yeah. So today I show you some papers, for example. Yeah. Step. What kind of step that we have to do if we want to write the paper. So tomorrow, uh, please one of you, each of you, please present what kind of, let's say, oh, I want to focus on implementation, or I want to focus on the proposing a framework. Okay, and then what kind, what step I will do in our research. So the research methodology. You can present to me your research methodology, your plan to finish this research. Okay.
What time for tomorrow?
Okay, for tomorrow, uh, 2 p.m. Philippine time. Is it okay? Just like last time.
Okay. But Artvin Ong, can you be the host for tomorrow? Because tomorrow I will have a conference. So, is that okay? Can you send the link? Set the link.
Okay, I'll send it to you.
Can you send to the chat right now the link for tomorrow? Just make one.
Oh,
Yeah.
okay.
So everyone can use the the Zoom link for tomorrow from you because I have to
The conference.
uh attend a conference. Yes.
Oh, Dr. Yogi attend the conference in Sunday.
And Monday. I have 11 papers. I have 11
Wow.
papers.
And you present all of them or some
No,
present?
only three.
Oh,
Only three. Actually, it should be the students, but they disappear. So some of them disappear. So I have to be the one who shoulder the. Yeah, they disappear. So that's why I'm kind of like, oh, why you disappear? I mean, because I don't know, because they thought that they already finished the class and they don't want to do
I see,
anything
I
with
see.
me. But I'm like, yeah. So because every class for master program, I always do the conference,
Okay.
but not for PhD. Yeah, for my PhD class, I will just keep it and then do revise more and more, and I will submit to journals, of
Yeah,
course,
of
for the
course.
PhD
Let's
class.
see.
But for
Need to.
master, yeah,
Mm,
yeah, yeah, I don't want to sell it too quick and to sell it too cheap in a conference. So I don't want to do that for PhD. But for master, but they disappear.
it's okay, Yogi. So if they disappear, my suggestion is your last slide is, if you have any question, please contact this. You can give the email.
No, but the problem is like I have to make the PPT, I have to record I have to make the video, and yeah. So and sometimes the topic is like not my topic, like
Oh yeah,
Lean
it's
Six
difficult.
Sigma. Yeah, I'm like a Lean Six Sigma. Yeah, I know I Lean Six Sigma, but
Yeah,
I'm
I
not
I
really,
understand. Mm-hmm.
yeah, yeah. But it's okay,
Mm-hmm.
next time, like I will force them to make the video before I give the grade. My grade last term.
Yeah, so
Okay.
you know, more if we more study,
Experience.
yeah, if we study more, I mean, we study from undergraduate, master, and doctor,
Yeah.
and more study. We only focus on more specific field of study, right?
Yes.
Mm.
Yes. Yes. More specific field. So yeah, basically like that one, but it's okay.
Okay, so tomorrow,
2
this
p.m.
one,
Manila time.
Arvin. Thank you, Arvin.
So that is the link. That is the link for the tomorrow. Okay.
For tomorrow.
Welcome, Dr. Fer. Oh, Dr. Yogi, should I record the session tomorrow or no?
I think no, because tomorrow is a secret, right? I mean,
Yeah.
Yeah,
All
no.
yeah,
our studies. Yeah.
no, yeah, no for tomorrow because tomorrow is it should not be recorded for tomorrow because it's individual consultation. Yeah, it's
Okay.
confidential. So yeah.
Mhm, mhm. Okay. Okay. So for today, any question? I hope you can get some inspiration from the existing papers for your study. Honestly, I choose one paper because I get inspiration from Artvin case. So this one, this predicting student performance, because this paper also has so many variables, just like Artvin paper. You have so many variables, so I think you also can learn from this paper.
Yes, Dr. Fer. I was looking at how it was constructed.
Yeah, when I read this, oh, okay, this is very similar to Artvin, so that's why I put this in my slide today. Okay, so no more questions for today.
No, but I think they are ready for tomorrow. Yeah.
Yeah, okay. So for tomorrow we focus